Welcome back to The Deep Dive. This week, we're doing something a little different. We're focusing exclusively on one company.
Meta AI.
Exactly. And just 1 week, January 4th through the 11th. But it was an incredibly dense week.
Oh, absolutely. This isn't just a list of product updates. We're really dissecting a massive strategic realignment. We're pulling from fairs, technical papers, infrastructure deals, and even some pretty raw leadership conflicts.
Right. And our mission here is to unpack Meta's very decisive shift toward becoming what you could call a vertically integrated industrial power.
And that's really defined by three pillars this week. You have energy sovereignty, a huge push into autonomous agents, and then this crisis of scientific integrity.
It feels like a definitive moment.
Yep.
The company seems to be moving to what they'd probably call a superintelligence-first paradigm.
Right. It's not just about the models anymore. It's about controlling every single layer of the stack, from the electrons powering the data center all the way up to the code.
And here's the headline that really sets the stage for that ambition. I mean, this one was unexpected. Meta is betting its future on nuclear energy.
A huge bet.
A commitment to securing 6.6 gigawatts of power. 24/7.
Which tells you the AI race isn't just about who has the best algorithm anymore.
No, it's about who controls the biggest, most stable power grid. Okay, let's unpack this and maybe start with the developers.
That whole pursuit of power makes so much sense when you see the efficiency demands they're putting on their own research stack. Meta's open source side, it just keeps delivering these incredibly specialized tools, all aimed at efficiency and code quality.
And our first story is a perfect example. It's from Meta's Fair Group, headlined, Language Models as Compilers, came out globally on January 7th.
So what happened here is they published a paper on a new two-stage method for generating code.
Okay.
Instead of just asking the LLM to spit out executable code directly from natural language, which can be messy.
Right. It often is.
The LLM first generates this structured compiler-like thing called an intermediate representation, an IR.
So the IR is kind of like an architectural blueprint. It has the logic, but not the exact syntax.
Exactly. And then that blueprint gets fed into a second system that just deterministically compiles it into clean, executable code.
So why does that shift matter?
Well, it decouples what LLMs are good at, the creative reasoning part, from what they often fail at, which is strict syntactic precision.
And the results.
A 15.2% absolute improvement on the human evil plus benchmark for Python. And this is critical. It cuts syntactic errors by over 70%.
Wow. That is a huge boost for any developer.
It's massive.
Okay, so moving from code quality to deployment speed, the PyTorch team open-sourced something called TorchForge.
Yeah, this dropped on January 9th. It's basically a PyTorch native reinforcement learning library.
And it's designed to simplify what exactly?
Large-scale fine-tuning. I mean, when you're using RL to align these huge LLMs, stability and coordinating across thousands of chips is a complete nightmare. TorchForge is built to handle that.
And they tested this on a pretty big cluster.
512 GPUs using a verifier system they call Weaver.
And here's the metric that really stands out for innovation pace.
It allows researchers 4 times faster iteration.
4 times.
Yeah. A step that used to take 6 minutes now takes about 1.5. When you're training foundation models, that kind of reduction just accelerates the entire cycle.
And a final, very practical release on the same day.
A fine-tuned version of the code Llama 34B instruct model. But this one is super targeted.
Extremely. It's optimized just for generating valid schema-conforming JSON and YAML.
Which, if you've ever built a data pipeline, you know, an LLM promising JSON and then delivering junk is a constant headache.
It breaks everything downstream.
Exactly.
Yep.
So this specialized model got a 98.7% valid JSON generation rate on their benchmarks.
And the base model was what?
84.1%. So this is a huge leap. It basically solves a long-standing reliability problem for AI-driven backends.
Okay, so we've seen how Meta is making its developers faster, its code cleaner. Now let's pivot from that internal tooling to the consumer stuff they showed off at CES.
Right, and the product announcements were all about the convergence of the Ray-Ban display glasses and the Meta neural band.
They're really pushing this idea of ambient computing, AI as a layer, not an app.
Precisely.
So the first headline from CES, January 6th, was the Ray-Ban display enhancements.
They added some really practical features. There's a teleprompter that shows your notes right in the lens.
And you can control it with the neural band.
With just subtle gestures, yeah. But the real key technology here, the thing that moves it beyond just a smart device, is the EMG handwriting.
EMG, that's electromyography.
Right. It translates the subtle electrical signals from your finger movements on any surface, your leg, a table, whatever, into text messages.
This feels like a meaningful step toward, practical neural input. But let me push back a bit. Is EMG handwriting actually practical for most people, or is it still kind of a lab demo?
That's the critical question, isn't it? They're betting that for subtle, hands-free, and most importantly, private inputs.
Right, like texting in a meeting.
Exactly. For that, EMG is way better than saying, "Hey, Meta," out loud. It's designed to be imperceptible.
Okay, that makes sense. And the glasses are also getting more useful in a traditional sense.
Yep. Pedestrian navigation expanded to 32 U.S. cities, 4 new ones: Denver, Las Vegas, Portland, and Salt Lake City.
But here's an interesting detail.
The international expansion.
Yeah, it's paused indefinitely. The UK, France, Italy, Canada.
The reason they gave was unprecedented U.S. demand, which signals they're really trying to saturate their home market first before they go and tackle global regulations.
And the neural band itself is expanding beyond just the glasses.
Right. They showed a proof of concept with Garmin for a unified cabin car interface.
So you could control your car's infotainment with finger gestures.
Simple EMG gestures, yeah. Change the music, adjust the volume without touching a screen. It shows the band is meant to be a universal input.
They also announced a collaboration with the University of Utah.
For accessibility applications, which is really interesting. They're looking at integrating it with the Katraski program.
Which lets people with limited mobility ski using neural inputs.
Yeah. It signals they want to position the neural band as critical infrastructure, not just, a cool gadget.
And one last thing on the virtual side. On January 8th, they launched the AI World Builder Toolkit in Horizon Worlds.
This is a suite of AI tools for creators. It lets you generate 3D objects, textures, even simple interactive elements just using your voice.
So it has, 5 core tools? Like an object generator?
And a logic script assistant, yeah. The goal is to solve the content problem that always plagues these virtual worlds.
By lowering the barrier to entry.
Dramatically. If you can just describe a custom world and have the AI build it, you're going to accelerate content growth globally.
We've covered the software acceleration, the interface moving into the real world, but all of that runs into a hard physical wall.
Power. Massive, reliable, uninterrupted power.
Which brings us to the foundational bet. The multi-decade bet on securing physical resources for AI at a planetary scale.
This is their pivot to what we're calling industrial sovereignty. January 9th, Meta announces these landmark nuclear energy projects. They're trying to unlock up to 6.6 gigawatts of power by 2035.
6.6 gigawatts. I mean, that is an absolutely massive number. It's like powering a small city. Why so much?
Because training these next-gen foundation models like their Prometheus supercluster in Ohio, it's not like a normal data center.
How so?
Traditional cloud computing has peaks and valleys in usage, but AI training demands constant, dense, nonstop power for months, sometimes years on end.
So grid stability becomes a competitive advantage.
It becomes everything. If your training run gets interrupted, you've just lost millions of dollars and weeks of time.
And their strategy here is pretty broad. They're working with Vistra, TerraPower, Oklo.
It's not just about buying power. They're actively helping build the future energy grid.
So on one hand, they're extending the life of existing plants. Perry and Davis-Bessas in Ohio, Beaver Valley in Pennsylvania.
Which gives them immediate, reliable capacity. But they're also investing in next-gen nuclear. They're expecting Oklo's small modular reactors in Ohio by 2030 and TerraPower's Natrium units by 2032.
The message is crystal clear. By locking down this power, Meta ensures it can run its AI workloads. And they're framing this whole infrastructure bet as essential for, quote, American leadership in AI innovation.
And while they're securing the electrons, they're also optimizing the silicon to use them better. The PyTorch team announced advanced GPU optimization through the Triton compiler.
Warp specialization in Triton. That's the headline.
Right. The compiler introduced this thing called AutoWS to generate optimized code specifically for their Hopper and Blackwell GPUs.
Okay, for those of us who aren't compiler engineers, what does that mean?
Think of a GPU as a huge orchestra. Getting the best performance, what engineers call roofline performance, usually requires a human conductor to manually tune the music for every single instrument.
Which is impossible at that scale.
Exactly. AutoWS automates that job and makes sure every GPU core is playing the right note at the right time.
And the speed up.
A stunning 1.5 to 2 times speed up over stock Triton on their new B200 GPUs. It basically maximizes the return on their massive chip investment.
So you have this incredible picture of industrial might, securing power, optimizing chips, speeding up
A
developers.
true full-stack approach.
But now we have to pivot hard because while Meta was announcing all this, its internal leadership was basically imploding.
It's a week of massive tensions,
Hmm.
organizational, geopolitical.
Yeah.
It all came to a head.
And the most explosive story came out on January 5th, the Llama 4 benchmark integrity crisis.
Yeah. LeCun, the outgoing chief AI scientist, a deep learning pioneer, publicly admitted that the Llama 4 benchmark results were, his words, fudged a little bit.
Fudged. He said they used different models for different benchmarks to give better results.
Which is a huge breach of scientific reporting standards.
Okay, but wait. If their own AI chief is calling the results fudged, doesn't that undermine trust in every single metric we've just discussed, including the safety improvements they also announced this week?
That is the question hanging over the whole company now. And LeCun didn't stop there. He then publicly criticized the new AI chief, Alexander Wang.
From the Scale AI acquisition, he's only 29.
Right. LeCun called him young and inexperienced, pointing out he doesn't have a research background.
The tension there is so clear. LeCun's comments expose this deep strategic disagreement. He's leaving to start his own lab focused on world models.
And it just underscores this internal shift away from pure academic prestige towards pragmatic, revenue-focused execution, which is what Wang represents.
At the same time, they're facing major geopolitical headwinds on a huge acquisition.
The Manus AI deal, a $2 billion-plus deal for a Singapore-based autonomous agent startup. This is key to closing their commercial agent gap.
And on January 8th, China launched an investigation into it.
Yep. China's Ministry of Commerce is reviewing the deal for potential violations of export control. This matters because Manus started as a Chinese company before it moved.
And it was a rocket ship, $100 million in annual recurring revenue in just 8 months.
Which is why the China investigation is targeting what's being called Singapore washing.
We should explain that term.
It's this pattern of a company, originally from China with sensitive IP, relocating to a neutral country like Singapore before it gets acquired by a Western company.
The idea, from Beijing's perspective, is to sidestep IP and export controls.
Exactly. So this review introduces serious friction and uncertainty into a really strategic acquisition for Meta.
And lastly, despite all this chaos over benchmarks, they did make a move towards more transparency.
They did. On January 5th, the Llama team updated the public model card for the Llama 3.1 405B model.
It now includes detailed results from a whole new battery of safety benchmarks.
Things like prompt injection resistance, bias quantification, it's all in there.
And strategically, what does that new data show?
It shows a 40% reduction in harmful output rate compared to the previous model. So while the company is facing an integrity crisis from the top, this team is trying to set a new bar for responsible documentation, trying to regain trust through data.
So after all that, what does this mean for you? We've just walked through Meta's aggressive transition into a full-stack industrial intelligence utility.
Yeah, they're pivoting hard towards industrial sovereignty, securing 6.6 gigawatts of nuclear power, optimizing the silicon. They're making sure they control the physical foundation for their superintelligence vision.
And at the same time, the organizational tension is just profound. A research pioneer resigns amid a benchmark scandal, followed by this huge acquisition of commercial tech.
It underscores that shift away from academic prestige towards just pragmatic execution. It feels like the only benchmark that really matters to them now is winning the industrial race.
And the products, the EMG handwriting, the world builder, they show that AI is moving off your screen. It's becoming an ambient layer integrated into the physical world around you.
Designed for seamless, hands-free interaction.
So here's the paradox that leaves us with. You have this push for unprecedented energy scale, these decades-long bets on clean energy to sustain compute. But at the same time, you have an admission of compromising on reporting integrity to win the current narrative. So what's the true non-computational cost of winning this race? What benchmarks should you trust going forward when the stakes are this high?
Until the next deep dive, stay curious and keep asking the difficult questions.